Hey everybody, welcome to question 21.3 solution guide. So they're giving us the heating curve of water here, just showing all the phase changes as we increase the energy and increase the temperature. So they have some explanations for what's going on in this graph. Make sure that you read those, understand all of these vocabulary terms for phase changes, melting, freezing, evaporation, condensation, and you're understanding what's different about the phases of matter. We're just going to be analyzing these true or false statements down here, and the majority of these are discussing the energy that is associated with these phase changes. So what we're going to do is we're going to study this energy diagram so we can see that anytime we are specifically just heating up the temperature of our substance, not changing the phase, but just changing the temperature. So whether we're warming the water up or cooling the water down, cooling the steam up or cooling the steam off or heating the steam up, and then also warming up the ice or cooling the ice off. All of those processes, when we're changing the actual temperature of our substance, we're changing the kinetic energy. When we start to change the phase, so when we make ice melt or we make water freeze, notice that it all occurs at 0 degrees Celsius, so the temperature isn't changing there. Because the temperature is constant, we're not changing the kinetic energy, but if we start to melt something, during this melting process, we're still increasing the amount of energy, as in heat, that we're adding. We're adding energy. So if we add energy during this process, we can't say that there's no change in energy. But if there's no change in kinetic energy, then we say that there's a change in potential energy. So when we change the phase of something, we're changing the potential energy. If we melt or if we evaporate something, we increase the potential energy. And if we condense or if we freeze something, we decrease the potential energy. In terms of the kinetic energy, for the kinetic energy, if we warm that ice up, warm that water up, or warm that steam up, we're adding kinetic energy. And if we decrease the temperature of the steam, if we decrease the temperature of the water, or decrease the temperature of the ice, then we're removing kinetic energy. So if we're looking at these statements now, for the first statement, it says that heating steam is an exothermic process which decreases the internal energy of the system. Well, if we look here and we look at steam increasing its temperature, so steam starts out at 100 degrees Celsius and then it warms up from there. Steam is only able to move up and to the right on this graph. As we move to the right, we are adding energy. So the processes of steam heating up would be an endothermic process because energy is going into the system. So this is going to be a false statement. For the second one, it says that condensation is an exothermic process because the system gives off energy. So then if we go back to our graph and we look at condensation, we can see that condensation process is moving from right to left. If we move from right to left on this graph, that means that we are removing energy from the system. We're taking joules out. If we're taking joules out, that means energy is being released, which is an exothermic process. So this is going to be a true statement. For the third one, it says that the freezing of water is an endothermic process because the system absorbs energy. If we, my bad, if we look at our heating curve and we look at the melting of, or the freezing of water, as water freezes, it moves from right to left again, so we're removing energy from that water. If we're removing energy from the water in order to get it to freeze, that makes it an exothermic process because the system would be releasing energy. So it's going to be a false statement. For 4, it says that the evaporation is an endothermic process because the system is absorbing energy. If we look at the evaporation process, we can see that we're now moving from left to right here. So if we move from left to right, that means we are adding energy. So this is going to be an endothermic process. We're increasing the energy of the system. For the fifth one, it says that as water is heated, the system is absorbing energy from the surroundings. As water starts to increase its temperature, it also needs to be, it's moving from left to right. So that means it's also adding energy. This energy has to come from some source. And then in this case, we're assuming that there's an external source of heat, which would be our surroundings. So the system would be gaining heat from those surroundings in order to heat its water up. The sixth one says that the melting of ice is an exothermic process because the system absorbs energy. If we look at our melting diagram, we can see that melting, we're moving from left to right. When we melt water, we are adding energy. We're adding energy to that ice in order to get it to transition or change its phase into water. So that means that the melting of ice is going to be an endothermic process because the system is absorbing energy. So this is going to be a false statement as well. The last one says that the boiling point of water, 1 atm, 373 Kelvin, so that's going to be 100 Celsius, says that water and steam are in equilibrium with each other. If we look at what's happening during this phase change process, we can study this as an equilibrium reaction. We have water and steam both simultaneously existing at this point. We have neither of the phase for sure. Those phases are transitioning, so they're said to be in equilibrium with one another. So this will be true. At any point where we're horizontal on this graph, we're in between phases, and those phases are said to be in equilibrium with one another. So at the line segment BC and the line segment DE, these would both have their phases in equilibrium. And then we're done.